So the formula for calculation of kinetic energy is actually Ke, which is equals to 1 over 2 mass multiplied by velocity squared. So we are told that we should actually calculate the initial kinetic energy before the collision and the kinetic energy after the collision for question number B. So basically what we can do, we have to say that Ke, we should specify that kinetic energy before a collision, and say total kinetic energy is equals to 1 over 2 mv squared plus 1 over 2 mv squared. So after saying this, you are actually going to substitute. So this is going to be the kinetic energy for the car. This is going to be the kinetic energy for the truck separately, or vice versa. You can just put the truck using the first one, or substitute information for the car on the second one. It's your choice. But then I'm just going to use the first one for the truck. So you have 1 over 2, and then the mass of a truck is actually 4,500 plus 4,500 multiplied by its velocity, which is 20, and then we square it, plus 1 over 2 into the mass of the car, which is 1,000, multiplied by its velocity before collision, it's 15 squared. Then we use our calculator. So we have 1 over 2 multiplied by 4,500 multiplied by 20. The 20 is actually squared, so the answer is 900,000. It's 900,000, and then we go on and calculate for the car. So it's going to be 1 over 2 multiplied by 1,000 multiplied by 15 squared, which is equals to 112,500. And then you add those two plus 900,000. You have 1,012,500 joules of energy. So that's how basically you go about calculating it. And then you go ahead and calculate the momentum, the kinetic energy after a collision. So you write kinetic energy after collision. So the kinetic energy after the collision, you're still going to say Ke, total kinetic energy after the collision is going to be equals to 1 over 2 mvf. So basically, I'm not going to write 1 over mvf squared plus 1 over mvf squared twice, because after a collision, we actually had one connected system like we did with momentum calculation, where we just said mvf. So in this case, we are actually going to say that it's 1 over 2 into the combined mass of the car and the truck, which is going to be 5,500, into the final velocity of the system, which we calculated, and it was 19.09 meters per second. So we have 19.09 squared. Then we go ahead and use our calculator. So we are going to have 1 over 2, 1 over 2 multiplied by 5,500 multiplied by 19.09 all squared, which is equals to 100,217, 100,217, 177.28. Remember to always round off your answers to 2 decimal places. So you're going to have kinetic energy of that much. So if you check this kinetic energy, you can see that they are actually not equal. The kinetic energy after the collision is actually less than the kinetic energy before the collision. So this simply means that the kinetic energy is not conserved. So this will actually give you an idea of what type of collision is this one. So the following question number C, it says that explain the difference in your answers for B. So the difference in the answers for B, it actually tells us that the kinetic energy for this collision is actually not conserved. That's basically something that you have to say. You have to say that the kinetic energy before a collision is not equal to the kinetic energy after the collision. Therefore, kinetic energy is not conserved. And then the question that follows, number C, question number D, it says, was this an example of elastic or inelastic collision? And give a reason for your answer. So this was actually an inelastic collision because the momentum was the only one which was conserved, but the kinetic energy, it was actually not conserved, because after our calculations at B, we saw that the kinetic energy before the collision and the kinetic energy after the collision was actually not conserved. So I hope you enjoyed this video. Be sure to hit that subscribe button and that bell notification icon so that you do not miss any content from EduPen. The next video, it will be about impulse. So I'll see you on the next one.